Hello and welcome to the Keystone Education. This is Pratik Korde and we are doing complete geography classes. This is the third lecture of this series. Now as far as the course is concerned, we are doing NCERT. Okay, and in NCERT we are going to start a new chapter, which is Volcano. So in this topic, broadly we are going to discuss about the definition of volcano. Then we'll talk about the classification of volcano. Then we will talk about the lava and the types of lava which comes out of the vent. Okay, then we'll talk about the landforms. We'll talk about both, that is intrusive and extrusive. Intrusive is something is below crust and extrusive is above crust, or we can see it. Then we will talk about certain landforms which are associated with a lava as well as volcano, and then we'll talk about certain examples of volcano. So let us start. So as far as volcano is concerned, we have to understand that so volcano basically includes the movement of molten rock, that is magma onto or towards the earth's surface. So if let us assume that this is a volcano. Okay, so this process is basically volcanism, and a volcano is formed when molten magma in the earth's interior escape through the crust by vent and fissure in the crust accompanied by steam gas. See, there are various gases which comes out of volcano along with magma, which is hydrogen sulfide H2S, then sulfur dioxide SO2, hydrogen chloride, hydrogen, carbon dioxide. Okay, so these are certain gases which comes out of volcano along with magma, and there are also some pyroclastic material which comes out of the volcano. Pyroclastics are basically the adjective which is used to denoting rocks fragment or ashes which are erupted from volcano. So this is basically alright. So that was the pyroclastic material. Now we'll talk about the classification. Classification of volcano. As far as volcanoes are concerned, they are classified majoritarily, which are based on 3 parameters. The first is frequency of eruption, meaning that in the recent past if it has erupted or not. If for a longer period it is not erupted, that as far as human can recall, it is called as extinct. Second is dormant, and third is active. Active one erupts frequently or have erupted recently. For example, Barren Island, which is, where is this Barren Island and volcano? Search about it. The second is dormant volcano, which is basically not engaged in recent activities, and extinct is possible where not erupted in human history. So that comes under extinct volcano. The second is based on mode of eruption. First is frequency, second is mode on eruption. The first is central type, second is fissure type. In the central type, eruption through a vent or opening, that is central type, and fissure type is basically the magma, it flows through a deep elongated cracks. For example, we see the example of Deccan Trap here, that comes under fissure type. So the important thing is mode of eruption. There are two, central and fissure. Third is based on characteristics of lava, and this is the area where question can be framed. So there are basically two types of lava, basic and acidic. Okay, if it is acidic lava, it is going to make a composite volcano. If it is basic, it is going to make shield volcano. Now we'll discuss this thing, that is types of volcano. First is acidic, second is basic. So as far as acidic is concerned, acidic lava is concerned, it is light color, then it is highly viscous, Third is, if it is highly viscous, it means it flows slowly. Here you can take an example of acidic like honey and water. So the way honey, it is highly viscous and it flows slowly, and when it will flow slowly, it will make steep sides. Then it will also lead to explosion. Recently there have been various mountains for near about Indonesia. Okay, you can cite the example near Sunda Strait. There was a little mountain which got erupted, volcano which got erupted. So that is one of the example. It may lead to explosion and pyro. The important things are, I think, covered here. The second is basic. As far as basic lava is concerned, basic lava is hottest and it is highly fluid, and it is rich in iron, magnesium, and it lacks silica. As far as acidic is concerned, there is excess of silica. Then presence of iron makes it look darker. Then it forms thin sheet, and it is highly fluid. That topic I think we have discussed. It flows quietly. There are various videos of Fiji that you can check on YouTube. Okay, you can go and check these videos on YouTube, that how slowly and quietly lava flows. Then it will make volcano shield or dome. These are the two types of volcanoes which it makes. Now this lava, acidic or basic, when it is, consider this to be a volcano. Okay, if this is the volcano and this is the vent. Okay, and then there are some certain features. So the features which are found outside and on the ground, for example, if this flows and then makes a plane out of here, it will be floodplain, that is extrusive. This volcano extrusive. When this sill, basically it is called as dike, and this is also the domes. So these are the intrusive: phacolith, baccolith, batholith, sills. This will be intrusive, and when they'll be exposed to the outside, it will be able to see them. Now first we'll talk about the intrusive structures. We'll talk about intrusive landform. Sometimes the molten matter is not able to reach to the surface and instead cools down at a very slow and gradual time, but at great depth. So slow cooling allows big sized grain, that is large grain, to be formed, and hence the granite is shining example. We have discussed this in the rocks. Okay, so granite is one of the shining example. So this rock appear on the surface only after when this soil will be weathered, eroded, and then there will be certain structure which will come out. Okay, then the molten magma, when intrusion horizontally along the bed of sedimentary plain, it is called as sills. Okay, so when consider an example, we'll learn it this way only, with an example only. Okay, so this is the big one, batholith. Okay, which is basically the storage of all magma. Then you'll see that the horizontal lines, okay, this horizontal lines will come along the sedimentary, because this is nothing but the sedimentary rocks, okay, that lava have made its way through. So this particular, I'll change the color for the better. Okay, so this portion, the horizontal across the batholith, this will term it as a sill. Alright, the second is a dike. So the molten magma intrusion vertically along the wall of igneous rock is called as dikes. Okay, even here you can see that this will lead to a structure like this, that will be dike. Even here you can find this type of structure or this type of structure. Even here it will be called as dike. The third is laccolith. Laccolith is igneous mound with a dome-shaped upper surface. Now, as far as this batholith is concerned, the magma will reach to the volcano, but at some time it will happen that it will reach here, but it will not go beyond this, or it will not find any gap through which it percolates above. So there will be a construction of this type of structure. It will be called as laccolith. Lapolith, basically like a lap, saucer shape. Okay, like a saucer, so that will be lapolith. and this will be the batholith, that is the huge mass of igneous rock. Now so this is all about the terminologies which are used. Now as far as the extrusive rocks are, because we have talked about them, extrusive, no extrusive. The shining example is basalt plain, Deccan Tract. Alright, so these are this is the example. Now hot magma from within the earth flows out onto the surface as a lava and explode violently sometimes. That leads to the pyroclastic materials which comes out of the volcano and releases into atmosphere along with the gases. So this is opposed to intrusive rock in formation, because it will come out and it will be sudden. So as in intrusive rock we find big size crystals which are formed, this does not happen in the basalt or extrusive rock. So there are various extrusive rock forms, line forms, that we are going to talk about. The first is lava plain, which is also called as basaltic plateau. For example, Snake Basin in USA, okay, and Deccan Plateau in India, and Iceland is also an example of lava plain. Second is lava dome. Second example is lava dome or shield volcano. So what happens if this is the ground level and this is a source, that is batholith, and when it finds its way to the surface, this lava, it flows on and it continuously flows on. Alright, so instead of it making like this type of structure, it spreads along, and that is the shield volcano or lava dome. Okay, the next is cinder cones. So if we talk about cinder cones, it is less fluid and large crater and steep slope. So these are the characteristics of cinder cone, that is less fluid, large crater, and steep slope. As far as lava dome is concerned, the examples are Kilau and Mauna Loa. Kilau and Mauna Loa. And cinder dome, as far as cinder domes are concerned, there are various examples. For example, Mount Pericutine, then Mount Nauvoo, etc. Now these are confined in the valley, okay, that lava bridges. Now there are certain other things like lava tunnel. Now what will happen if this is a sedimentary rock, okay, and this is the area which is basically made by lava and reach to surface. Now this batholith is dry, okay, so this basically will be an open tunnel from this place to this place. Yes, there will be some clogs in between, but this is a tunnel which have been created. So this is basically called as lava tunnel. The next is volcanic dust, and which comes under the pyroclastic material. And fifth is dust and ash, and it makes black snow. Okay, so this was all about the volcanoes. Now we'll talk about certain volcanoes. Okay, the first here in this race that we are going to talk about is composite cone. Under composite cone they are basically, or they are commonly called as stratocone. They are called as stratocone, with main conduct and subsidiary dike and pipes. So the characteristics of this composite is such that there is one, if this is the volcano, this is the main vent which will be connected to batholith, sill, lacolith, this is lacolith, this is saucer shape. Okay, so there will also be dikes. Okay, so this is basically the characteristics of composite cones, where it has steep walls. Okay, so you can see that it has a steep wall and sticky viscous lava which flows, but it does not flow very long, it flows till here. Okay, and then this will continuously, it will go on increasing. So that's the composite volcano. For example is Mount Etna. Mount Etna was also in news. I have told you that it is in Italy, but you have to find on which island it is located. This is the best example as far as the parasitic cone is concerned. Now interestingly, composite volcano, that is Mount Stromboli, it is called as, this is important, okay, it is called as lighthouse of Mediterranean. Lighthouse of Mediterranean, and hence it is important. Now the next thing is distribution of volcano. We'll do a little type of world map. It won't be exactly similar, but you will have an idea that yes, it is something like that. It is not lit, I won't say it is proportionate. Alright, so just consider it to be a world map. I have tried to draw it, but I understand that. So this is Africa, Europe, Asia, Australia, South America, North America, and India. So the distribution of volcano, this is important. You see that the volcanoes, they are basically clustered or crowded along the circum-Pacific ring of fire, or Pacific ring of fire, which includes around 2/3 of the world's volcano. And although there are few active volcanoes found along Atlantic and Mediterranean Sea, but if you take the world's 2/3 of the volcano, you will find them around Pacific ring of fire. So by Pacific ring of fire, I mean this is the Pacific Ocean, okay, Pacific, this also Pacific. I think I should have drawn it in such a way that you should have been able to see them, but you have to understand that this particular, that is whole area of Indonesia and even the Japan and this little Manila. Okay, so it also we have to consider. Then the area continuously will do this thing. Okay, so this is basically the distribution according along, and you'll find that even individually there are various spots. Okay, and even if we talk about this particular thing, that is the mid-oceanic ridge, which is very prominent in the Atlantic Ocean, and this is Indian Ocean. Okay, so here also you'll find earthquakes, even volcanoes, not now, but that is the earlier time that we are talking here. Even Africa, the continent, will find across the globe, will also find these spots in Indian Ocean as well. So I hope you understand it, the distribution of it. Now there is very small topic which will complete and then end the volcano. Certain terminologies, for example, geysers. So what is geyser? So geyser is a fountain of hot water. It is a fountain of hot water, and the superheated steam from earth beneath in which water is heated beyond boiling point with explosion. So with explosion. So the world's major geyser are concentrated in Iceland. Okay, then Rotorua in New Zealand. Okay, then the Yellowstone National Park of USA. Yellowstone National Park of USA. Here you'll find that the Old Faithful geyser. It is alright, and the next thing is hot spring. Hot spring is rather relatively common, and water rises without any explosion. Hot water without explosion. Okay, so these are certain topics that we have completed as far as the volcano is concerned. In the next video, when we meet, we'll discuss the other topics such as earthquake, climatology and others. If you haven't subscribed to this channel, I request you kindly please subscribe this channel. Thank you.